One of the absolute worst mistakes you can make on an algebra test is taking an expression like this and doing this. Oh no. Because you see, x plus 2 squared is actually a product of binomials in disguise, namely x plus 2 times x plus 2. Making a mistake like this will have a catastrophic impact on your math grade, not to mention carrying very bad algebra habits forward into the rest of your studies of mathematics. So if that's incorrect, how exactly do we expand an expression like this, where we have a product of two binomials? Well, we're going to need a new tool, and that new tool is FOIL. Yeah, not that FOIL. FOIL is an acronym that stands for firsts, outsides, insides, lasts. And we're going to use that acronym to help us expand and simplify this x plus 2 times x plus 2 expression. But first, be sure to expand and simplify the like and subscribe button so that you can start expanding and simplifying your knowledge. So what does this acronym even mean? Well, the F stands for firsts, meaning the first term in each set of brackets. And for us, that is this x here and this x here. And the FOIL process tells us to multiply these two terms. So just like when I use the distributive property, I like to draw little rainbows connecting the two terms that I'm multiplying. So in this case, I have x times x, and I'm going to write the result right here. X times x we know is x squared, not 2x. That is a simple exponent laws problem where I've got powers of the same base, x times x, both with the power of 1. I add those exponents to get x squared. The O in our FOIL acronym stands for outside, so the outside terms on our expression. The x in this case is on the outside. The 2 here is also on the outside. So the outside terms for us were this x and this 2. And you guessed it, we're going to multiply those just like we did with our first term. So I'm going to draw an arrow from x to 2, and I'm going to say x times 2 is, of course, 2x. Okay, that's my outside part of my FOIL acronym. Moving right along, we have our inside terms. Now, our inside terms are the terms that are on the inside of the expression, or this 2 and this x here. Those are my inside terms. And of course, I'm going to draw some rainbows, but this time I'm going to draw them underneath to keep things clean. I have 2 times x. Okay, well, we know 2 times x is 2x. We just did that, right? 2 times x is 2x. So I'm adding 2x here. And lastly, the L in the FOIL acronym stands for lasts, or the last term in each binomial, right? The 2 here and the 2 here. And I'm going to draw myself one last rainbow connecting the 2 and the 2. And I know that 2 times 2 is going to be 4. So I've got plus 4 at the end. Okay, I've now successfully expanded my product of binomials, but I have not simplified it yet. Because if you look here, I've got some like terms, right? I've got a 2x and a 2x. Well, if I have 2 x's and 2 more x's, I have 4 x's. If that bothers you, pretend you have 2 Pac-Mans and 2 Pac-Mans. You've got 4 Pac-Mans. Okay, so x squared plus 4x plus 4 will be my expanded and simplified expression for x plus 2 squared, or x plus 2 times x plus 2. Quite a bit different than if you made that mistake and just distributed that 2 into the brackets like I showed you at the beginning, right? You'd be missing that 4x term, and that would be disastrous. All right, moving right along to a more complex example here. You can see I've got 2x plus 3, a little coefficient in front of my x this time, times x minus 1. And I've got a negative here, right? So a little bit higher level of difficulty, but the process is going to work exactly the same. We're going to apply our FOIL acronym here. We're going to multiply our first terms, right? Our outside terms, our inside terms, and our last terms. Okay, so let's start with our first terms. Okay, 2x times x. I know that those are two powers with the same base, that x, right? X to the power of 1 times x to the power of 1. I'm going to add my exponents to get x squared, but I've got that coefficient of 2. So 2 times x squared is going to be my result there. 2x times x is 2x squared. Okay, that's our first. Next, we're going to move on to our outside, or our 2x times negative 1. Now, 2x times negative 1 is just going to be negative 2x. Okay, I'm just going to change my sign. And moving right along to the inside part of our acronym, we've got 3 times x, also known as 3x, right? And if you're wondering about the signs here, we're just going to keep the sign that results from the multiplication, right? Positive 3 times positive x is positive 3. 2x times negative 1 was negative 2x. So whatever sign I get when I multiply, I bring it along and I just plop it right into my expression. And lastly, moving along to the last terms, 3 times negative 1, I know is going to be negative 3. All right, so I've got a nice little expression here. Not quite simplified yet, because remember, we got to collect some like terms. And this one's a little bit more complex with our like terms, because we've got a negative 2x and a positive 3x. Okay, so a little bit of integer work here. But picture this like a thermometer, right? If it's negative 2 degrees and it goes up 3 degrees, it's 1 degree, right? But we're not working with degrees, we're working with x's, right? So our end result here is going to be that 2x squared, and our little collected like terms here is just going to be plus 1x, also known as just x, and our negative 3 coming along for the ride at the end of our expression. Okay, nice little simplified expression after applying the FOIL acronym to 2x plus 3 times x minus 1. All right, moving along to the final boss of this video on the FOIL acronym, you're going to see this mysterious 2 hanging around the outside, and that makes things really confusing for a lot of students, but I'm going to show you a little handy trick here that's going to make things nice and simple. Basically, what we're going to do is just ignore that 2. Pretend it's not even there. Okay, imagine we don't have that 2. All right, it's that simple, except not really. Don't forget about that 2, because it is still there. All right, but imagine the 2 wasn't there. How would you approach this problem? We're going to just multiply 3x times x using the first part of our FOIL acronym, 3x times 1 using the outside, the inside is negative 1 times x, and again, the last is going to be negative 1 times 1, okay? We're going to just use FOIL just like we did with the other examples, but we have a little 2 at the front. Just ignore it. It's there. Don't bother it. But what we do need to do is open a set of brackets, because the whole FOIL process that we're going to apply here is going to take place inside that set of brackets, and that 2 is going to multiply by each of the terms that we produce. Okay, so just ignore the 2 for now, and let's just tackle the FOIL process one step at a time. Okay, 3x times x, we know that's going to be 3x squared, and we've got 3x times 1, that's just going to be 3x. And we've got negative 1 times x, also known as negative 1x, or just negative x. Negative 1 times 1 is going to be negative 1. Okay, a nice little expression after applying FOIL. It's not simplified yet though, because remember, we've got some like terms. Okay, 3x and negative x. Those are like terms. We're still going to ignore that 2. All right, it's not bothering you. Don't bother it. Just write it. And we're going to say we have 3x squared, and we're going to collect our like terms. 3x minus 1x, well, that's just going to be 2x's. Okay, 2x, and that little minus 1 at the end. All right, so what we have now is just a nice simple distributive property problem, right? We're not multiplying binomials anymore, so we don't need FOIL. We can use the distributive property to simply multiply our 2 into the brackets by each term. Doing that is going to result in 6x squared, right? 2 times 3x squared. 2 times 2x is going to give us 4x, and 2 times negative 1 is going to give us negative 2. Okay, nice little simplified expression after applying the FOIL process. Now, common mistake for a problem like this, some students will choose to take that 2 and distribute into each set of brackets like this. And now if you do that, your final answer is going to be larger than the correct answer by a factor of 2. You've accounted for that 2 twice. Now, if you don't like saving that 2 and bringing it along for the ride, what you can do is pick one set of brackets and distribute it into that set of brackets and then apply FOIL. But whatever you do, do not distribute that 2 into both sets of brackets. I'm not going to show that here to keep this video brief. All right, so we had some fun playing with tinfoil, and we expanded and simplified some products of binomials. Next, you're going to want to head over to this video right here, and I will see you there.